Black holes are some of the most terrifying and mysterious objects in the universe, regions so dense that not even light can escape. But recent theories suggest they may be more than just cosmic voids. In fact, what's inside might look disturbingly familiar. That's because scientists might have just found something hidden deep within black holes – us. In March 2025, the James Webb Space Telescope, or JWST, captured images that could change everything we thought we knew about the universe. If you're unfamiliar with the James Webb Space Telescope, then here's a bit of background. Launched by NASA in December 2021, this telescope is our most powerful eye into deep space, capturing the cosmos in unprecedented detail. Since its debut, it's transformed how astronomers view the early universe. Among some of the most interesting finds made by the James Webb Space Telescope were images of as many as 263 galaxies beyond our own. And it was these other galaxies that actually held the first indicator that would lead to the black hole discovery. When the JWST launched, scientists expected a roughly even split, half of distant galaxies rotating like the Milky Way and half in reverse. But what the telescope found shattered that assumption. Of the 263 galaxies captured in its images, nearly two-thirds were spinning opposite of the Milky Way's direction. So what gives? What makes our galaxy one of a third of outliers all spinning counterclockwise? The images from the telescope seem to imply that there is actually a preferred direction of galactic rotation. But why isn't ours spinning this way in this confusingly coordinated cosmic chaos? Well, that's where the effects of black holes come in, potentially playing a bigger hand in our universe than scientists might have initially thought. While it's not entirely clear what causes roughly one-third of observed galaxies to rotate counterclockwise, astronomers are focusing on two main theories. The first is tied to black hole cosmology, the idea that matter and energy are pulled into a black hole and could exit through a theoretical structure known as a white hole. Since we don't know yet what exists inside a black hole, or if anything can exist, this theory suggests that black holes and white holes could be connected as two ends of an Einstein-Rosen bridge, more commonly known as a wormhole. We know that black holes form when massive stars collapse under their own gravity. Building on this, theoretical physicist Nikodem Popławski from the University of New Haven proposed that the collapse could create not just a black hole, but also give birth to an entirely new universe on the other side, a white hole connected through an Einstein-Rosen bridge. In essence, it would be a cosmic gateway between universes, with all the matter and energy from one side being steadily funneled through into the other by the black hole's immense gravitational pull. So what does any of this have to do with rotating galaxies and the James Webb Space Telescope? Well, one of the explanations that came out of the JWST images of differently spinning galaxies indicates that maybe the universe was born spinning. It makes sense. In our own galaxy, planets orbit the sun, so it stands to reason that this kind of motion is a natural occurrence across the whole universe. But that also means that if the universe has always been rotating, then existing theories about the cosmos are incomplete. After all, none of us are billions of years old. So nobody knows where the universe started spinning from or if it had any observable point of origin. It is worth noting that black holes also spin, with the fastest being GRS 1915 plus 105, which clocks in at over 1,000 rotations per second. Spinning universes and black holes. It's a lot to take in, so let's break it down. One of the core ideas behind black hole cosmology suggests that our entire universe might exist inside a black hole. First proposed in the 1970s, this theory is gaining renewed interest as new images from the James Webb Space Telescope show unexpected galaxy rotations. To some scientists, that hints that we might be observing the inside of a black hole, because we're already in one, along with the rest of the universe. Now, that sounds like a bit of a reach. So before we figure out whether or not that's what the JWST images are actually telling us, let's get a little more detail on black hole cosmology. Also known as Schwarzschild cosmology, the idea was initially posited by physicist Raj Kumar Patria and by mathematician I.J. Good. They came up with a theory surrounding the Schwarzschild radius, better known to us as the event horizon of a black hole. Like we've pointed out, within this boundary nothing can escape. Not light, not matter, or energy of any kind. And Good and Patria suggested that the Schwarzschild radius is also the horizon of the visible universe. Taking everything we've talked about so far, this theory carries with it another implication. If a black hole is one end of an Einstein-Rosen bridge and a white hole is the other, then every black hole in our universe could be a gateway to a separate miniature universe. A cosmos condensed by the black hole's immense gravitational pull, And yes, you heard that right, there are black holes in our universe. The nearest to us is known as Gaia BH1, located at 1,500 light-years away, with the furthest being QSO J0313-1806, which is 13 billion light-years away. The biggest black hole in the universe is TON 618, with a mass 66 billion times that of our Sun, while the smallest is just shy of 4 times the Sun's mass. If Schwarzschild cosmology is to be believed, then each of those could theoretically contain an entire universe, much in the way that our universe is seemingly contained within a much larger black hole. Think of it like Russian nesting dolls, except each doll doesn't just contain one smaller doll, but several. That's our universe and all of these smaller ones trapped inside of black holes. But is there a way that we could look inside these existing black holes to see into those supposed other universes? No, there isn't. It seems anticlimactic, especially for all of you who still think the multiverse isn't already played out, but it's actually a lot darker than you realize. Literally. Those universes, if they do exist within the black holes of our universe, would be unobservable beyond the event horizon. Remember, not even light can escape from the Schwarzschild radius, so no visual information can travel from inside the interior of a black hole to an external observer. This also means that if our universe is also inside a black hole, then we too might exist within a far larger universe than we can comprehend. It would be far beyond the bounds of, well, everything that we can observe and everything we can't. As if that wasn't already hard enough to wrap your head around, it raises an even bigger question. If black hole cosmology and the Einstein-Rosen bridges are real, then where exactly are we and all of these other black hole-contained universes going? Does traveling through a black hole for long enough expel your universe out into another, through a white hole at the other side? Well, as far as we know, black holes are born when the core of a massive star dies. This heart consists of incredibly dense matter, far exceeding the density of anything else in the known universe. It is this incredible density that pulls all the other matter inwards, as well as light and energy, causing what's known as, we're not kidding, spaghettification. Yes, that is the actual scientific term. People often describe black holes as crushing matter. You'll see that idea a lot in science fiction, but in reality, when matter gets too close to a black hole, it is squeezed horizontally and stretched out vertically. This resembles a noodle and is how we get arguably one of the best terms in all of science. According to Poplavsky, the coupling of torsion, the constant twisting of space-time, and the spin of the black hole, along with the galaxies and universes within it, eventually become strong enough to stop matter from being compressed indefinitely. And that's a good thing, because what's the matter with matter? Well, compress it too much for too long and you get a singularity. And that's the core of a black hole, the point where gravity and density become infinite. And a singularity forming inside what might already be a universe-sized black hole. It's not exactly ideal, right? But according to Poplavsky, it might never reach that point. Instead, the matter inside would reach a state of extremely high but still finite density. That means that it wouldn't collapse into a singularity. Instead, it would bounce back like a compressed spring snapping outward. This bounce would cause a rapid expansion, and that intense gravitational shift could spark massive particle production, increasing the mass of our universe within the black hole. Poplavsky believes that this recoil could be what triggered the Big Bang. In other words, our universe may have begun inside a black hole, and everything we see today is just expanding outward, pushing back against the forces at the edge of the event horizon. Poplavsky explained that this would produce a finite period of cosmic inflation, and no, we're not talking about the space economy. It would explain as well why the universe on a large scale appears to be flat, homogeneous, and isotropic. All of that got a bit confusing. But according to black hole cosmology, every black hole could be creating a tiny universe inside it. These black holes act as one end of an Einstein-Rosen bridge, linking that inner universe to a larger parent universe on the other side, which exists beyond a white hole. But before you start packing for a quick trip to the parallel universe, there is a catch. The white hole exit can't be entered from the outside. So unfortunately, interdimensional travel via wormhole remains firmly in the realm of sci-fi for now. This would make our universe one of those smaller universes within the interior of a black hole, which itself exists in a larger surrounding universe. But how do you get all of that from a few high-resolution photos of other galaxies? Well, it all comes down to the fact that our universe doesn't spin right round. If other galaxies and the rest of the observable universe had a preferred axis and all rotated the same way, with the same bias for clockwise, well then we could all just pack this up. But the fact that not all galaxies spin the same way lends some validity to the idea that the universe was born within the event horizon of a black hole. Given that they form from stars or even the centers of galaxies, black holes also have their own axis of rotation. So it stands to reason that this would influence the rotation of a universe born inside of it. The preferred axis of our universe's rotation could have been inherited from our black hole. This could have also influenced the rotation dynamics of other galaxies that exist alongside ours. That could well be why the James Webb Space Telescope observed a clear asymmetry between the 2/3 of clockwise spinning galaxies and the 1/3 of counterclockwise galaxies. While the discovery that each galaxy rotates in its own direction does support the theory of black holes creating new universes and ours is inside one, there is another explanation to consider. There might have been more clockwise rotating galaxies observed by the JWST as a direct result of the Milky Way's own counterclockwise rotation. It was previously thought that the speed of our galaxy's rotation was far too slow to have any impact on the telescope's observations. But it's considered a possibility that the JWST's distance measurements for the deep universe need to be recalibrated to account for this non-negligible impact. Updating these measurements could help resolve some of astronomy's biggest mysteries, like why the universe's rate of expansion doesn't always add up, or how certain massive galaxies seem older than the universe itself based on current distance estimates. Maybe if scientists keep looking to the stars, we'll find out for certain if we really are all living in a black hole. Now go check out what is a white hole opposite of a black hole, or click on this video instead.